So just a couple of announcement types things. So again, Michael, thank you for asking the question. I am going to be recording all of my classes from this point forward. And I will show you on Wednesday what that's supposed to look like, and I'll tell you how to access them, but they don't exist online yet, but they will soon. So hopefully that'll be a resource we can take advantage of. I just gave the quiz back. Some folks did really well, some folks not as well. The good news is the quiz is just like this small little checkup. And so even if you have like a bad checkup, it doesn't mean it's the end of the world. We have these little checkups so that we can fix it before we get to the end of the world, which is on February 24th, right? That test is worth a whole lot more than this little tiny quiz. Tiny quiz is just a moment for me to say, hey, you're where you should be, or you need to do some work to get where you should be. We can talk right after class, okay? All right. The other thing about the quizzes, we have 10 throughout the semester. I dropped the lowest single quiz grade at the end of the course. So one quiz grade is just not going to count at all. So don't fret too much, but anyway, if you're doing well on the homeworks, then the quizzes should look familiar to you. Today we talk about rational expressions and equations, and just a heads up, I know we just had a quiz, but the idea with these quizzes is that they happen regularly, roughly once a week, just lots of little checkups so that nobody gets too far behind without a little notice from me. It says, hey, you're not where you should be. Our next quiz is on Friday, okay? Any questions on the calendar? Okay, then let's take a look. So we're on page 21, and we'll start here with number 1. Taylor? Okay, so we're not going to read these definitions, but you should know them just so that you're familiar with the words as I use them here, and also on a quiz or a test, I could say, identify each of these. Is it a polynomial? Is it a rational expression? Just kind of like a matching type thing. Number 2, Taylor? Okay, it should say 3, but my middle finger didn't quite get up to the 3 when I typed it, so E, Sarah? Okay, so domain, again, is the set of allowable inputs. There is one very bad number to divide by. What is that bad number? 0, right? We've been trained from a long time ago. Can't divide by 0. It is madness. So we do not divide by 0. So the question is, what value of x is the bad one? Can you guys look at that and decide what value of x is bad? X equals 5, right? That's the one that is bad. Now this equation you could just look at and know, oh, okay, x equals 5 is the bad one. But you know, if it were more complicated, then you might want to solve the equation. So you just write the bottom thing equals 0, and then you solve for x, and you get x equals 5. But this is a little bit weird in that I have just found the value of x that I don't want to work, right? Normally you find x and that's your winner. This x is a loser. So, but we're not very good at solving not equals. So we don't solve not equals, we just solve the equals, and we get x equals 5, and then we come up with our answer, which is the domain, set of all x such that x is not equal to 5. And remember, hopefully the symbols don't look as mysterious today as they did a week ago when we first started looking at them. Same kind of idea for part B. Are there any questions on part A? Okay, so in part B, again, we have division. And again, we need to avoid dividing by 0. So we say, okay, x squared minus 1 equals what number? We want it to equal 0. It's very strange what we're doing. We're finding the things we don't want. Okay, let me show you one way to solve this. Add 1, and then square root both sides. So we get x equals, what's the square root of 1? 1. Done, right? Plus or minus. Raise your hand if you did not think plus or minus in the last 10 seconds. It's okay to admit it. So some of us missed the plus or minus on the quiz. Not that big a deal, but again, If you actively take that square root, that's when you got to put in the plus or minus. Can I show you another way that maybe we'll avoid this issue because it's so easy to forget that plus or minus? Let's undo all this stuff here. And instead, I'm going to think factor. This x squared minus 1 has a particular form, a pattern that you guys maybe have seen before. What do the first things need to be to build x squared? X and x. Now it's weird in that there's no x term in the middle, right? Normally there's like a plus 5x or something sitting in the middle, but there's none in this case. How do you multiply two numbers and get 1? That'll be 1 and 1, and they're going to have opposite signs. And if you check, if you FOIL this thing through, you'll see that it works. It gives you x squared minus 1. Maybe in some previous life, you guys saw this formula as something called the difference of squares or difference of two squares, which if you just write the letters makes a cute word, difference of two squares. But however you recognize it, it's just a pattern that we need to be familiar with if we're not already. And then we're ready to split it right down the middle. Either the first thing is 0 or the second thing is 0. Either x minus 1 is 0 or x plus 1 is 0. Set both pieces to equal to 0. How much is x over here? It's 1. How much is x over here? Negative 1. This is how we can avoid forgetting that plus or minus. It's so easy to forget. But if you factor, you can't forget. You're going to get both of those. You're going to get both the plus and the minus just by solving the equations. So in this case then, domain is all the x's such that x is not equal to 1 and negative 1. Questions on that one? Okay, part C doesn't really look like parts A and B. First of all, it looks quite complex in terms of the highest power. You see something with a power bigger than 2 or 3, probably there's an easy answer, we just have to find it. We've been trying to avoid dividing by 0, right? Is there anything to worry about in part C? No, there's no division. So there's no chance we're going to accidentally divide by 0. So if there are no bad guys, then what's the domain? Domain is all real numbers. There's nothing to exclude. Everything works. We'll be fancy and write all real numbers in a couple of ways. You have choices. If you wanted to write it in interval notation, all real numbers, where do you start? Negative infinity. Start all the way at the far left. All real numbers, where do you end? Infinity. There you go, that's everybody. Okay. Every number you can name is in there. And if you want to be really fancy, mathematicians like to be compact and concise, right? Has anybody seen the fancy single symbol for the set of all real numbers?
Yeah, it's at R.
Yeah. It's like an R with an extra vertical line. That symbol right there, you can find it in Microsoft Word, is the symbol for the set of all real numbers. Okay, when you're ready, we'll go to the next page. And I think we're up to, where are, I completely lost. You were the last one. Thank you, Andy. Okay, so this one is far more complex than the first three. Let's identify the bottom problem first. What very bad value of x are we trying to avoid? 5. Okay, so x is not equal to 5 right off the bat. But then there's other stuff happening here. There's a square root and a fifth root. What are the bad numbers to stick inside of a square root? Negative numbers, yeah? You can't take the square root of a negative number, at least not in the real numbers, and that's what we're focused on right now. So this is the other warning. It talks about taking the square root of a negative number. That's a problem. So let's deal with that guy. So if I want to make sure that x minus 2 is not negative, well, hold on, let's pause. Get into the punchline too quick. So I want to make sure x minus 2 is not negative. Okay, so you could say x minus 2, let's see, not negative. So negative would be less than, don't write this. Negative would be less than 0, right? And then not negative would be that. Okay, mathematically this is correct. Mathematically, I have no earthly idea how to solve this thing. I don't know, I mean, I guess you could add 2 to both sides and hope that it works. It doesn't always work. So let's not write that. Instead, let's say, okay, x minus 2, 0. Instead of saying not negative, let's say something affirmative. What's the opposite of not, or what is not negative in an affirmative sense? Positive. So how about we do that? Okay, that will avoid all the negatives. There's one little thing that we're missing. There is a number that is not negative, but also not positive. 0, right? Is the square root of 0 okay or not? Square root of 0 is 0. It's fine. So we better include 0 in our list of possible answers here. So anytime you see a square root, you just automatically take the stuff and make it bigger than or equal to 0 every time. Okay, now I'm comfortable doing this. I can add 2 to both sides and get x is bigger than or equal to 2. Super. So I've highlighted the 2 things we found, not 5 and bigger than or equal to 2. And we have one more piece to this puzzle. That's this 5th root of x minus 8. I'm tempted to do the same kind of thing. X minus 8 bigger than or equal to 0. It's a 5th root. How is that? Yeah, you can take the 5th root of a negative number, no problem. You can take the 7th root of a negative number. The problem is square roots and 4th roots and 6th roots. Even roots are the ones that you can't have negatives inside, but odd roots are no problems. So I'm going to say odd root, no domain issue. So I want to say ignore it. I guess I don't want to say exactly that. I want to say analyze it and then decide it's okay to ignore it. Okay, so last thing that Andy read was write your answer in 2 ways. So I've got the highlighted things. That's my domain, so I'll just write it here. Set of all x such that, and then we pretty much just write those 2 things down. X is not 5, and x is bigger than or equal to 2. Joe? Yeah, let's talk about that a little bit. Okay, what do we think about, say, the square root of negative 64? Yeah, this is not real because you can't find a real number that when you multiply it by itself, you get negative 64. Okay. Can I find a real number that when I multiply it by itself 3 times, it gives me negative 64? What is that number? Negative 4, right? Because negative 4 times negative 4 gives the positive 16, but then you have a third negative 4 coming in here that flips it back to a negative. So it's because you have the odd number of factors that you're allowed to get to a negative. Good question. Okay, let's write it in a second way. Let's write it in interval notation. We got to have a good visual of what's going on here. I want all the numbers that are at least 2, but I want to make sure I toss 5 out of the picture, right? So if I'm starting this in interval notation, what's the smallest number that's allowed? It's 2, right? It starts at 2. In theory, it goes forever to the right, but we got to make sure we exclude what number? 5. So starting at 2, going forever to the right, toss out 5. So starting at 2, including 2, going until, so like it feels like 4, but if we say 4, then we're missing like 4.3. And so we say 5, and then we say not 5, right? Get all the way up to 5, but not that exact number. That's our way, remember, to exclude a single number. But then we got to pick up. And so where are we going to pick up? We're going to pick up exactly where we left off. And we're going to, again, exclude 5. I almost feel bad. It's like 5 is invited to the party, but then excluded, and then re-invited, and then re-excluded. It's, I don't know. This is how gossip starts, this kind of thing here. And how far do we go? Infinity, we go forever. And this is it. This says go from 2 to 5. Don't allow 5 into the party. Then pick up right there at 5. And again, don't allow 5 into the party, and then go forever. So really, we went from 2 forever. We just left poor 5 out in the cold. And if we want to be really, really mathematically precise, okay, if you just put a comma there, I'll understand what you mean, and I think I'll give you full credit for it. But we want to be really, like we're budding mathematicians, right? We want to use the symbol. Anybody know the symbol that goes in there? It's a union symbol. Looks like a capital U. That's our way of kind of putting sets all together. Okay, that is as hard a domain question as I will ask. It had 2 parts. It had the division, and it had the square root. And if you can understand those 2 parts separately, all that's left is to kind of figure out how they work together. Any questions on that one? Okay, we will go to Sam, number 5. Okay, so that's our summary. That's everything we said about domain. Okay, let's go to Tyler for 6. Okay, 12/15. We're going to do this a long way, much longer than you would ever actually do this because you guys are excellent at reducing fractions. But 12 factors, right? What times what? 3 times 4. It also factors as 6 times 2, but that's not useful. You can see that that's not going to be useful, right? 15 is what times what? 3 times 5. Oh, 3 times 5. So when I reduced, what do I get? 4/5. Again, I'm going to write this out a little bit longer than you guys ever would. I'm going to write it as 2 fractions, 3/3 times 4/5. To convince yourself that they're equal, how do you multiply fractions? You multiply straight across. So I just pull them apart. It's not a natural thing to do, but it's allowed. And then how much is 3/3? Is 1 times 4/5. And that's just 4/5. Okay, I never need to see the details that we just put in here. You guys are way past this in terms of your math level. But I just want to highlight that there is a really good reason that, that these guys cancel. And it's because you can take the 3's out of both of them and then separate those 3's off to the front. And then 3/3 is just a different way to write the number 1. So let's go to this before part for Michael. Okay, we're going to see foo-foos a bunch this semester. And a foo-foo is just a fancy form of 1. A fancy form of 1. What was the particular form of 1 that we saw here? Where was 1 in this problem? Was this 3/3? That is a foo-foo. It is a fancy form of 1, and I'd rather just not have it appear there, so we pull it out and get rid of it and see that it's really just 4/5. Okay, fancy form of 1. Let's try 7, Katrina. Okay, so let's take a look at part A first. All right, first thing I want to say, you see the x squared, so we cancel them, right? And then I see x on top and bottom, we'll cancel them. 10/8, that goes down to 5/4, right? Okay, if you do any of those things that I do, I will have some health problems. And my health insurance is okay, but it's not super, right? So please don't give me health problems by doing any of that stuff, all of which is illegal. But some or most or all of which looks okay if you're not exactly sure what you're doing. Certainly the x squares look like they should be able to cancel. It's the same on top and bottom. It's the same as this 3 over 3, right? What's the difference between canceling the 3's here and canceling the x squares down there? That's it. Yeah, this guy right here is a multiplication. Multiplication is your friend. If you see multiplication, you can cancel things that look the same on top and bottom, okay? So those guys cancel because it's times. But if you see additions and subtractions, none of them is ready to go. Thank you. So don't cancel anything. Don't think about canceling if you see additions and subtractions. So let us get rid of all these things. Oh, wait. Let's try factoring instead of doing that. Okay, I trust that you guys are good at factoring. If I am wrong, become good at factoring. So, looking for two things, they're going to be x squared. What do they need to be? X and x. Looking for two numbers that multiply to -10. There's not a lot of possibilities. You need to pick the one that's the ones that add up to 3 in the middle. +5 and -2. Okay. All right. So a bunch of us saw that, knew that in our heads. A bunch of others of us look at that and think, where did these mysterious numbers just appear from? Okay, wait, let's pause. Okay. So if you cannot do that, then you have some reviewing to do. This is a skill that you acquired or honed in 106, and it is a skill I'm going to call on a bunch this semester. If you need practice with it, let me know. I will point you in the right direction. On the bottom, it's the same idea. Okay, let's get some hands here. What are the magic numbers that are gonna work on the bottom? We'll go all the way in the back to you are Ben. Ben says +4 -2. Anybody agree with Ben? Super. Again, if it's mysterious, it's not necessarily a problem. It just means you got work to do and you should do it soon. Factoring is something I want you to be able to do this. Not necessarily like that, but I'd like you to be able to do it. All right, now, what's the point of factoring? It turned additions and subtractions into what operation? Multiplication. Multiplication is our friend. You see multiplication, that's when we're allowed to cancel, right? X minus 2 is the same top and bottom. We'll cross them off, and we've got our answer over there. X plus 5 over X plus 4. Okay, pause, we gotta pause. Wait for me, you're getting ahead of me. Okay, I had said if you see additions or subtractions, don't even think about canceling, right? What's in the middle of the parentheses that I just canceled? In the middle of the parentheses that I canceled, there's a subtraction, X minus 2, right? Okay, so what am I saying? Can you or can't you? You can cancel when multiplication is the main operation, and the thing on top and bottom is exactly the same. The main operation is that red multiplication in the middle. Okay, even though I said if you see addition and subtraction, beware, I'm not thinking of that subtraction sign as being subtraction. I'm thinking of X minus 2 and X minus 2 as being exactly the same thing. I don't care what it looks like. It's the same. And so I'm allowed to cancel, but only because we had multiplication. Okay, so we have reduced. That complicated thing with all the x squareds is really another way to write x plus 5 over x plus 4. What we have done is similar to taking 12/15 and rewriting it as 4/5. We would all agree 4/5 is better? Good. And for the same reason, let us agree that x plus 5 over x plus 4 is better. It's equal, but it's better. In terms of domain, just wanted to mention this one thing right here. Set of all x such that, what's the bad number for x on the bottom? -4. X is not equal to -4. There's another bad number. Taylor says +2 is a bad number. What do you think? Are we allowed to plug 2 into this blue fraction here? What do you get on top? And x is 2. 7 over 6. That seems legitimate, right? 7/6 is a perfectly good answer. Are we allowed to plug in 2? We're allowed to plug in 2 into the blue thing. But 0 on top is actually okay, but it's a good thing to bring up. Like you're not allowed to divide by 0, but 0 on top is fine. Can you plug can you plug 2 into the original typed fraction? The answer is no. If you try plugging x equals 2 into this original, well, you'll get the same thing as what we had over here before we canceled. You'll get 0, top and bottom, but 0 in the bottom is very bad. So let's just make an observation here. Find domain before you cancel. So the 2 came out because, well, Taylor, how did you get the 2? Right, so we look for denominator before we cancel. So Sam, take a look. That's the original denominator, right? We need to make sure we don't divide by 0. This was our factored version. It's still equal to what it was, but it just looks different. What value of x would make this piece equal to 0? -4, and that was still there, so we wouldn't miss that. But what value of x makes this piece equal to 0? It's 2. So factor, find the domain before you cancel, then cancel. Okay, part B, quite a bit easier actually. Cancel the x's. Having palpitations. Anybody want to cancel the x's? No. Good. Very good. So yeah, so I don't know what the answer is here. Already reduced or some flavor of that. Just let me know you know you're not supposed to do anything. Okay, we are going to go to 8. Katrina, did you read? Yes, we'll go to Ben, number 8. Okay, so let's take a look at part A. So what we're going to do here is we're going to kind of revisit all the arithmetic that you guys did on fractions. How do you multiply fractions? How do you divide fractions? How do you add or subtract fractions? But now we're going to do it with expressions, with x's. So same exact rules that apply, but I got to say, if you didn't like all those things for fractions with numbers, you're really not going to like it when there's x's involved. Okay, let's take a look at this first one. It's a division problem. So first thing I'm going to do is remember a rule that I learned back when I was learning this stuff, and that's that when you have two fractions divided, you keep the first fraction, you change the division sign to what? Multiplication, and then you flip the second fraction. So affectionately, somebody taught me this as keep, change, flip. Keep the first fraction, change division to multiplication, flip the second fraction. After class, if you want to know why that's a good thing to do or why it's a legal thing to do, just see me. But right now, we're just going to say it's keep, change, flip. That's what you do when you see division of fractions. Okay. What's the main operation in the middle? Multiplication. Multiplication is still our friend. It means we can cancel if we can find things that look the same. Are either of these guys ready to be canceled? No. What's bad? What do you see up there that makes it? It's subtraction. Likewise, addition is bad. You cannot cancel unless you have identical copies of the same thing or all multiplication. So how do you turn subtraction into multiplication? Factor. Factor first. Okay, can you guys check with your neighbors? You're going to attempt to factor 4 different things, numerator and denominator for both fractions, and then check in with your neighbors as you work. And if you feel like you're making progress, definitely check with your neighbor. Make sure they are at least moving towards someplace. And I think I saw lots of folks that had the right factoring, so we factor everything. Factor first, that's the 2 most important words for the day. Did I make a mistake? It's okay, right? Factor first. And now we have turned all these additions and subtractions into multiplication. That's a times, that's times, that's times, all times. Anything on the top with anything in the bottom. Don't feel like it has to be in the same fraction for it to cancel. You could cancel the thing from the top left with the thing from the bottom right, as long as they're the same. And canceling is one of the most satisfying things that I do in an algebra class. So we're gonna just be happy as we cancel. So what cancels? All right, so the x plus 5 and the x plus 5. It's just so happy. We just, all right, and then x plus 4. Go with the x plus 4. Anything else? How about the x's here? X and x? No, right? I have a child at home. I mean, seriously, we gotta just take care of Ian. Don't do this. And then we just write our answer. So don't do any extra work. The answer in this case is x minus 5 over x minus 4, x plus 1. If we need to find the domain, we should have done it before we canceled. Did it ask us for a domain? No, but if it did, you're right. Before we cancel, that's the time to do it. The bad numbers are 4, -4, 5, -1. Please don't feel obligated to FOIL out on the bottom. Like, you just leave it in factored form. That's the best form, actually. Just leave it. It's done. Yeah, so remember when you multiply fractions, you just go straight across the top and straight across the bottom all together. Questions on that one? Okay, next page. Now you may be wondering why division came first. Seems like adding and subtracting is a lot easier than multiplying and dividing. And it's true, except for fractions, where adding and subtracting fractions turns out to be harder than multiplying and dividing fractions. So let's take a look at B. 3 over x plus 1 minus 2 over x. When you add two fractions, what do you need to do before you get to actually add them? You need the lowest common denominator. You cannot add fractions until they have the same denominator. And the denominators here are x plus 1 and x. And I need to make them the same. I need to find the lowest common denominator. Okay, this is where things get real tricky. I'm going to write my two fractions, and I'm going to find the denominators that I need to build. So first of all, I see an x plus 1 over there. I'm just going to put it. And then I see an x. I'm just going to put that. Haven't done anything. In fact, I'll just copy the top as well. 3, 2. Just kind of building some space so I can make my lowest common denominators. Okay, this is where we look and we say, all right, I've got one denominator with an x plus 1. Well, the other denominator better have an x plus 1 in it as well. Just has to be there. So I'm going to copy that x plus 1 right over here. But I've cheated. You can't just put an x plus 1 in the bottom. What else do you need to do? Put it on the top. And the reason it's okay to just put that in is that this is called what? That is a foo-foo. That is a fancy form of 1. Are you allowed to multiply by 1? Sure, it doesn't change anything. But it sometimes gives you stuff in a form that you can deal with. So foo-foos are good. See if you can put in the right foo-foo in the first fraction. You need the denominators to be the same. So ask yourself what's missing and then put it in. So what's missing? X. And if you multiply the bottom by x, better also multiply top by x. So it turns out that we figured out what the lowest common denominator is. It's that, x plus 1 times x. You could just multiply through. You don't even need to. I'd encourage you not to. Just leave it. Just leave it. Now, sometimes I can't look at it and know what the LCD is. I just have to kind of put some blank space in and then fill in what's missing. And then I figure out, oh, look, that's what the LCD is. Okay, so let's finish this now that they have the same denominator. On the top, I have a 3x over, and then I'll just copy x plus 1 x minus, and then we can distribute the 2x plus 2. And then the point is that if you have the same denominator, what happens when you subtract the fractions? What do you put downstairs? The same denominator. As soon as they have the same denominator, you merge them together and you put the same denominator just once. Don't put a 2, don't square it. That's just the denominator. But then on top, we get to bring these two fractions together and make 1. Don't write this. Does it look good? So as we get to know each other, you'll discover that when I stand here with one of these awkward pauses like I'm doing now, it's because I've made a mistake and I need you to find it. Why is it x minus 2, Sarah? That's one thing, right? That's one denominator. We all recognize it as one denominator because it was in its own fraction. Thank you, numerator. That is one thing. It's not true anymore, just to leave it there. It was clear it was one thing being subtracted. The whole thing was being subtracted. But as soon as you put it into one fraction, you got to throw in some extra grouping symbols. So we say, oh, this was a family before. It's still a family. We need these extra symbols to say, hey, this is still a family. Those are the symbols we need. It was all being subtracted. The whole second fraction was being subtracted from the first. You need to put parentheses so that we still see it's the whole thing being subtracted from the first. It's so easy to miss that. And I'm so mean because I'll give you an opportunity to miss it on the next quiz, but I'm telling you now, make sure that if it's one thing being subtracted, you still recognize it's one entire thing being subtracted. So instead of x plus 2, what does it become? I think that's x minus 2 now. That's the right answer. Questions on that one? Okay. Let's take a look at part C. Does it look easier or harder? Yeah, those denominators have squares. It's harder. Let's give it a shot. If we were going to play the same game that we did as up above, then we would, don't copy this either, we would do something like this. X squared minus 1 is sitting here, and we'll leave some blank space, and then there's a plus. And then we can kind of fill in the pieces. There's an x squared minus 1 in the bottom. What's missing? Like that, yeah, like do you see that if I just stick this whole thing over here, then I can make them match up, and what's missing over here? X squared minus 1. We buy it? Have I found a common denominator? Yes, I have. That's perfect. That's a common denominator. It's not the lowest common denominator. And can I say it would be kind of equivalent to something like this? What if you had like let's say 3/12, and then we'll add to that 5 over, I don't know, let's say 9, something like that. Couldn't we say, well, what's missing on the bottom here? What could I put down there to kind of make a common denominator? Can I put a 9 there and then 12 over here? Won't that work every time? Just fill in the other thing and build them all up. So what do we have here? 9 times 12, is that 108? Is 108 a common denominator? Sure. Is it the lowest common denominator? No. What do both of those go into? 36. 9 and 12 both go into 36. 36 is the lowest common denominator. You're perfectly welcome to work with 108, but I would choose 36 every day. And I'll say it's equivalent to that, but it's even worse because you're perfectly welcome to do what we did here, deal with the 108s, but we're going to get to a place where we have to simplify the fraction, reduce the fraction at the end, and we're going to have some things that we can't even factor. We can't even reduce. We just don't have the tools, and it's not even like I'm holding out on you. There's going to be things that you can build here that I don't have the tools to factor. So this is not only more work, it can lead you to a place where you can't get to the simplified answer. We just don't have the tools. So it is worth our energy to find not just any common denominator, but the lowest common denominator. So let's see if we can do that. This is also one of my favorite things to do. It's that one is the big eraser. I just feel like so powerful when how effortless I make this. This is not easy. I just make it look easy. Okay, let's find the lowest common denominator. I think it was either Eric or Matt. What did you suggest to do first? Factor. Let's factor. X squared minus 1 is really and then we factor the other one as well. Okay, now that it's factored, you know what I can do? I kind of want to, no, not what I want to do. I kind of want to grab some of this and move it over a little bit. I don't know if I can. That's not exactly what we want. Okay, so let's just write it again then. Okay, so the goal is to, I'm just going to squeeze something in, apologies. I see an x plus 1 and an x minus 1, x plus 4 and x minus 1. See that they have something in common? What's the same in both? X minus 1. You don't need to repeat it. This is where we're going to avoid the duplication. What is this guy missing that's over there? X plus 4, right? That's what's over there. It's not here yet. So if I stick an x plus 4 there, then I better stick an x plus 4 here. And then we play the same game with the second fraction. What is he missing? That's not over there. Is an x plus 1. And then I better complete the foo-foo. Okay. And now we're in a position where we can do something with these guys. I'll distribute here. 3x plus 12 plus, we distribute over there, x squared plus x over the one denominator, which is now the same in both. This is correct, but I just want to highlight this is a good moment to make sure you are grouping things. Anything that was part of like its own fraction before should probably be in parentheses down here. What should be in parentheses first? 3x plus 12, it came from the one thing, and then separate parentheses around the x squared plus x. It won't matter here because it's plus in the middle. But if it was subtraction in the middle, we'd have been wrong without those parentheses. Okay, and then we're just about done. Combining terms up here, x squared plus 4x plus 12. Do not feel obligated to do anything with the bottom. Just leave it every time. Factored form is the best. Yeah. So Iris makes a good observation. If you could factor the top, you probably should. You know, that's like part of simplifying. Turns out it doesn't factor. Probably spend a few moments and then just say, okay, we're done. Questions on that one? Eric. Yes. So I put the x squared first just because I like having my highest power first. And then we combine terms. You have a 3x plus another x. How much is that? So the subtraction happened on the previous problem because there was a minus sign in the middle here. We ended up having to subtract the two groups. I like that way of saying it. So we did subtract them, but that's because that was the operation from the beginning. So that subtraction sign right there ended up right down there, and we subtracted the groups, as you say. Here, it's an addition, and so we added the groups. Other questions on this one? Okay. Let's. We're going to skip number 9. Number 9 is something called a compound fraction because it's fractions within fractions. I'm just going to give you in English my one hint, and then I think there's some stuff in the homework for you to practice. But here's my hint. Multiply top and bottom by the LCD of all fractions. So that's my rule of thumb for simplifying fractions within fractions. Multiply top and bottom by the LCD of everything. And you can try this one later on, and you'll see that the LCD is x times y. Take a look at that another time. Now let's try some equations. So I think we were up to Joe for number 10. Keep going. Okay, what's the big difference between part A and all the other stuff we've done today? It's an equation. Very different from the things we've been dealing with so far. We've been dealing with expressions, things that are just sitting there that we wanted to rewrite, put in another form. Here it's an equation. The answer is not going to have all this gobbledygook with x's in it like the previous questions. The answer is going to look like x equals, and then you'll have some numerical answer. All right, 1 plus 1 over x equals x. This is the first time this semester we've seen an equation where there's an x where? In the denominator. Okay. And in fact, take a look at part B. Where do you see x's? In the denominator. And is there a c on the next page? Yep, x is in the denominator. So what we're trying to tackle now, the new thing for right now, how do you solve an equation where the x's are in the denominator? All right, some of you might have a technique that you've already been using where you find LCDs and deal with it that way. If it works for you, keep doing it. I'm not going to ask you to change a thing. I'm going to show you the way that I think is the easiest. And that's to multiply both sides. Let's see, was this written out? Yeah, multiply both sides of the equation by the LCD. There's only one denominator. What is it? X. So I'm going to multiply everything by that LCD, which is x. Okay, I'm going to do this in like a little bit slower than you need to do. Don't feel like you need to write down every step that I'm writing when you get practice with this. So first thing I'm going to do is put parentheses here times x, parentheses here times x. Whatever you do to one side, you must do to the other. Now on the left-hand side, we distribute, right? That x goes in and multiplies by everything. So it's x times 1 plus x times 1 over x. That's distributing the first x. Equals what? X, oh yeah, we'll fix that. On the other side equals x squared. And we see that we just get x plus, but then what happens to that fraction? It cancels, right? And in fact, that's the whole point. That's why you put the x there, was for it to immediately cancel with that denominator. Don't put nothing. You got to have the placeholder. It's a plus 1. And that's equal to x squared. Okay, solving this equation is going to be straightforward from here. So I just want to stress the part that we did, which was to get rid of all the fractions, right? No more fractions in that equation. And I also want to point out a warning that it's really easy to, in your head, say, okay, I'm going to multiply everything by x. And when you multiply this by x, what happens? What do you get when you multiply that by x? You just get 1 because it cancels. And so it's really tempting to say, okay, this becomes a plus 1. And let's see, that guy was already a 1, and this guy was an x. What did I forget to do? Or maybe it looks so bad that you don't even recognize the mistake I made because you would never do something silly like this. What I did is I multiplied this term here by x, but I didn't multiply that by x. I have to multiply everything by x. Even if the x cancels, like it cancels right here, but it's still there. It's there before it cancels in the one spot. So I'd encourage you, until you have a lot of practice with this, just write it all out. Put those parentheses and distribute like we did. Let's undo some of this stuff. Okay. How would you solve this equation from here? So square rooting both sides seems like a fine idea because that will get rid of the x squared, right? But what will it introduce? You'll have plus or minus. We can handle that. Michael? Yeah, that's what we're going to do. So it seems tempting to just take the square root. It's a good idea because that's how you get rid of the x squared, right? Just make it x. But the problem is there's still x's on the other side. And so we can't have x equals, but then still have x's in the answer. Okay, so let's try this other suggestion where you bring everybody over to one side. And then how do we solve that? Factor, if we're lucky. If we're not, quadratic formula. I always look at that and think that I can factor it. Like it looks like it should be factorable. It's not. I'll just say use the quadratic formula. I'll tell you what the answer is. It's 1 plus or minus square root of 5 over 2. It's Joe. And then what would you do? Where am I here? Okay, so Joe wants to do this. X squared minus x equals 1. Do we buy it? Just move the x over. So far, so good. And then you wanted to factor. X comes out and then x minus 1. This? Yes. Good. Right? And then doesn't this look just like how we normally do factoring and then solving? Make x equal 1 or make the other thing equal to 1. So it's really, like, it looks good. It looks comfortable and familiar. Unfortunately, there's a flaw. That equation is perfect, but the very next thing that you said wasn't true. You said x equals 1 or x equals 2. And here's the problem. The reason that we make it equal 0, I'm just going to cross this off and pretend it's a 0. If I multiply two numbers and I get 0, what must be true? One of them must be 0, right? If you multiply two things and you got 0, one of them has to be 0. If you multiply two things and get 1, does one of them have to be 1? Can you give me two numbers that multiply to 1 where neither of them is 1? Two numbers that multiply to 1, but neither of them is 1.
Minus 1 and minus 1.
Minus 1 and minus 1. How about some fractions? Two-thirds. Two-thirds times what? Will give me 1. Yeah, I'll write that as this fraction. 2/3 times 3 halves. Isn't that equal to 1? If you multiply two numbers and get 1, are you guaranteed? Yeah. So that's the problem, Joe, is that you're not guaranteed that either of these is equal to 1. Maybe the first thing is 2/3 and the second thing is 3/2. Or maybe it was 2/5 and 5/2. And so that's why 0 is an important number, and I'm really glad you pointed it out. So we have a moment to really think. It's not just a process. Like Michael said, get it equal to 0. So maybe Michael understands why 0 is important, or maybe it's just been drilled into his head, and he says, oh, you just get one side equal to 0, and that's what you do, because that's what the teacher said to do. But there's a reason the teacher said it. It's because 0 is that only number that when you multiply two things and get 0, one of them has to be 0. But it's not true for any other number. Okay, this 1 plus or minus root 5 over 2. So like you may have been wondering how I did that in my head so fast. So besides the fact that I'm just like a math genius, I will say that the positive version of it, that was a joke. I'm not a math genius. Maybe, I don't know. Maybe like mad genius or something like that. This 1 plus root 5 over 2 is a really famous number. Can you guys name a famous number that is given a letter? Pi. Yes? Pi is a famous number, but it's so important to us that we give it a letter. Pi. Can you name another famous number that has a letter? I, right? Imaginaries. We'll talk about them. But I is the square root of -1. Anybody know another famous number that has a letter? E. It's okay if you have not heard of the number E. We will talk about it later this semester. Anybody know approximately how much E is? Yeah, it's about 2.7. It's about 2.7. But it's a famous number, so we give it a letter, E. And in fact, on your calculator, just pull it up real quick, the three numbers that you guys just named, they're all here. It's going to be hard to see, but see that yellow I right down there? That's the I that we've been talking about. That's the imaginary number. There's a, again, it's hard to see, but there's a lowercase e right there. That's this 2.7 that most of you haven't heard of, which is okay. And then right there, that's pi. Three famous numbers, three letters, all three on the calculator. 1 plus the square root of 5 over 2 is another famous number. It has a letter associated with it. It's another Greek letter. It's phi. It didn't make it onto the calculator, but I will say if the people that made this calculator were going to put another number on there, this is probably the fourth one on the list. Like, in terms of importance. Phi comes up a lot of places in nature and architecture and art, and we're not going to get into it, but I think that there's some really good readable material online. If you just Google that phrase, golden ratio, you'll find lots of stuff. You heard of that? You have a book on it. Yeah. Okay. So let's go down to, yes, Eric. Yes. This one here? Can you share with us how it factored? Yeah. I fall into it every time. It looks like it should factor. Like -1 and plus, like, I don't know, like it looks like it should factor, but unfortunately it doesn't. Okay, let's take a look at part B. 1 over x plus 1 plus 1 over x minus 4 equals that thing right there. Same idea as before. I like to get rid of the fractions as soon as possible. You guys are with me, I'm sure. Multiply both sides by the lowest common denominator. Can you look at it and see what the lowest common denominator is? This takes practice and skill and more practice. I'm hoping that at some point you guys get there, where you can look at that and say, okay, definitely I need x plus 1, right? Definitely I need x minus 4. Do you need this guy too? I've seen it already. I already have an x plus 1. It's already part of what I'm planning. Do you need this one as well? I've got that one too. So the LCD is actually just the two things, x plus 1, x minus 4. That is the lowest common denominator. Okay, so this next part is a little bit annoying because we just have to copy the whole thing but give ourselves some space. but I think it's worth writing out. Really easy to go wrong on this kind of thing if you're not careful with the details. So just copying it again with some strategically placed spaces. Okay, everybody's getting multiplied by the LCD. So in those spaces, I'm going to put this blue LCD next to everything. Am I putting it top and bottom like I did before? Just putting it at the top, which feels like cheating. Whatever you do on top, you need to do on the bottom, right? That's what we did with expressions on the previous page. This is not an expression, this is an equation. With equations, you have some more freedom because you can do something to the right-hand side as long as you do the same thing to the left. What I'm doing to both sides is multiplying by this LCD. Not putting it top and bottom, just multiplying every fraction by the LCD. Okay, and then we'll take something fancy here. All right, so what can we do here? See some canceling? What goes away in the first one? X plus 1, top and bottom. Cross it off. I hope you saw it because now you completely can't see it anymore with the canceling. All right, so maybe we won't do it the canceling the fancy way. Okay. But we cancel. X plus 1 goes away in the next one. X minus 4 goes away in the last one. Both of them go away. And the point is that all the denominators go away if you do this right. So all we have here, x minus 4 plus x plus 1 equals x. A breath of fresh air. If you do it right, all the fractions go away and you get something reasonable. You turn those ridiculous equations with fractions in them into something reasonable. So what happens here? X equals 3. You can fill in the details. The really important step is that one where we copied it over with those big spaces. That's how you're going to get this question right. Is you copy it, you put the big spaces, and then you say I'm multiplying everything by the same thing. That's the LCD, which is in blue. And when you do that, all the denominators cancel. That's the point. Questions on that one? By hiding some of the steps. In more detail, that's a 2x minus 3 equals x. Yeah. Okay, when we're ready, we have one last one to do together on the next page. Same idea as before. I'm going to copy everybody. Oops, a little bit of space. Plus 1 over. Which means, again, we're looking for this LCD, lowest common denominator. Do you guys see that one of these fractions is not really ready to be LCD'd yet? You got work to do to find the LCD. What can you do with x squared minus x? Factor it. If you factor it, then you get to see some stuff that's there, but you just aren't aware of. You factor that x out of both. Now you see some duplication. What's the same in our denominators? X, which means in our LCD, we don't need both. We just need one of them. So In this case, the LCD is, again, the most complicated denominator there. That's everything. So I put that LCD next to both. I just want to pause for a second. Finding the LCD takes practice and skill and more practice. So I don't mean to gloss over it. There are a few people in this room who have been vocal contributors today, and they know how to find the LCD. I'm not assuming that everybody in this room can just find the LCD like that. It takes practice. Once we've got it, lots of stuff cancels. What goes away in the first spot? X in the second spot. Both. Super. So what's left over here? Just x minus 1 plus 1 equals 5. Yeah, some of you guys are on to me. I make these mistakes hoping that they look reasonable and that we catch them, and then we don't make them ourselves. It's very tempting to do what I did. I put the x minus 1, that red thing, next to all the fractions. I wanted to get rid of the fractions, and I did, but I cheated. I multiplied the left-hand side by x minus 1. I got to multiply the right-hand side as well. X minus 1. That's different. So it looks worse on the right-hand side, but that's just the way you have to do it. Okay, so we have like 30 seconds left. I'm going to write down what the answer is. You need to use either the quadratic formula or factor this guy. There's work to do. I trust that we can do it. I'm just going to jump to the answers. The answers are 0 and 6/5. 0 and 6/5. One of those numbers is very dangerous in terms of the original equation. Which one of those numbers is very bad? 0. You cannot plug x equals 0 into this equation, right? From the beginning, we could have looked at that and known that. So sadly, this is something that happens with fraction equations that we have no control over. You can do all of the algebra right, you can follow the process to the end, make no mistakes, and still get an answer that just doesn't work. It doesn't happen for very many kinds of equations, but fractional equations are one of those places where it does. So we need to reject anything that doesn't work.
I never arrived at a 0. I only found the other answer.
Someplace you might have canceled some. I can take a look at it. Okay, homework is in the usual place. Have a wonderful Monday. We'll see you in a couple of days. And